following presentation outlines the work and deliverables produced for Manifest, a project to enhance response to gas and volatile incidents. So why do we need such projects? Well, more than 2,000 types of HNS are regularly transported by sea. The volumes shipped are constantly rising, with more than 200 million tons of chemicals traded annually by tankers. This means a greater risk of accidents and pollution at sea. Accidental release of volatile HNS at sea can lead to the formation of toxic, flammable, or even explosive gas clouds that are potentially hazardous for the nearby population and environment. The gas clouds formed can travel a long distance in a short time scale, involving potential risks for the coastal population. These gas clouds are thus a unique challenge for marine pollution responders to handle. So what is Manifest? It's a European-funded project aimed at enhancing response to gaseous and volatile HNS incidents at sea. Running over 2 years until 2024, it involved collaboration from 6 countries and 9 agencies working together to develop tools and deliverables for the project. The project also actively invited the views of relevant agencies and organisations within an advisory board to ensure deliverables met what is needed operationally. As well as management and dissemination activities, the project also comprised 4 complementary work packages. One was focused on experimental data on the evaporation dissolution kinetics of volatile HNS. Another focused on the development of exercises, guidance and field training, while a third work package was dedicated to the development of new fire and explosion modelling modules. The final package was used to develop a decision support system holding all of this information for use by stakeholders. So let's look at these work packages in a bit more detail and firstly consider laboratory and pilot scale experiments. Experimental tests performed at Cedre involve physical and chemical experiments to assess the competition between evaporation and dissolution of volatile HNS. The work also involved the construction of wind tunnel apparatus bespoke to this project. The wind tunnel apparatus pictured here allowed continuous monitoring of air and liquid temperatures as well as mass changes within the HNS liquid. Tests included assessing evaporation kinetics of a range of selected volatile HNS and a constant wind velocity. Further tests studied the effect of wind velocity on the evaporation kinetics of selected HNS. These tests also looked at changes in temperature caused by changing wind velocity on evaporation kinetics. Key findings included the effect of wind speed on evaporation rates and also how the temperature is affected by the evaporation process. However, it was noted that changes in temperature were unlikely to be as significant in the field as they were in the laboratory. Experimental data were then used to update physical chemical properties in the Manifest HNS database to inform and update parameters for fate and transport modelling. As well as laboratory studies, testing was also undertaken using a sea trial. The aims of the sea trial were to assess the behaviour and fate of HNS in the open sea, to assess detection capacity of various sensors, and to validate and compare prediction models. The sea trial was undertaken in an approved area off the coast of Brittany. HNS were released into the open sea and a range of detectors were used to assess their ability to identify the slick and the gas cloud. Here we see another example of slick and gas cloud detection using SIGIS-2 from the Belgian Civil Protection Agency, and results from airborne detection using a multispectral camera. The sea trial identified strengths and limitations of a range of sensors. It also identified the need for further studies. The results were used to produce a catalogue of sensors available. The sea trial was also used to inform fate and transport modelling by experimental work with drifting buoys. Here we see model outputs for VO slick drifting. The sea trial produced a range of findings to inform model validation. As stated earlier, the development of a decision support system formed one of the key work packages in order to collate and make information available for stakeholders. The decision support system was designed to enable users to access information quickly and easily. This information includes a HNS database with access to over 600 HNS chemicals with over 100 parameters within each chemical entry. Decision-making guidance for public protection from gas and vapor clouds during incidents. A knowledge tool providing a repository of marine research and technical resources for response to HNS incidents. An online platform that enables preparation, development, and assessment of maritime HNS exercises. A common operational picture tool and viewer to enable efficient information exchange between incident stakeholders. Modeling apps for fire, explosion, and fate and transport modeling. Dissemination tools including informational videos and innovative materials such as a serious game to improve understanding and encourage team working. So that's manifests. Please visit the website if you want to know more and get access to the tools and deliverables produced on the project. But it doesn't end there. There's more to come. Manifest Genius is phase 2 and will look to build on the findings already achieved in the Manifest project. The project will continue to develop knowledge and expertise and will have a strong emphasis on sharing outputs with key stakeholders. The project will also have a strong focus on emerging propulsion technologies such as ammonia, methanol, LNG, and lithium-ion batteries. Thank you very much for listening. Merci beaucoup.